I know where there's some, right here in the hall, clerk.
No, Molly, not in there. I have enough.
Hello and welcome back. Here's the Zenith 60B. All the tubes are in. What we're going to do is start to power it up with tubes in. See what kind of action we get out of this Philco radio. We have to measure voltages for starters. We've marked the schematic, and let me show you on the computer how I marked this up. Let's set some expectations for ourselves by documenting on this schematic what we should find based on the Philco documentation. For example, we can start with the 42 tube right here and take a look at what Philco says we should expect for plate voltage on the 42, and that's 240 volts DC. So we'll make a note of that right here. The plate for the 75 tube should be 170 volts, and we'll talk about why that's different here in a minute. The 78 tube, likewise, should be 250, as actually you'll see it's supposed to be slightly higher than the plate voltage on the output tube. We'll try to explain that. We'll see if we know why that is. We have our target voltages for the plates of the tubes in place. Let's go backwards here a bit and see where some of this voltage comes from. If we look at our plate for the output tube right here, we can trace this back down through here to the cathode of the one of the cathodes of the 80 tube, the rectifier tube. So this says, we expect this to be 240 volts here, and we're going to drop a little voltage going through this coil, and we're going to drop some voltage going through this coil. This should be greater than our 240 volts. So we can make note of that as well. If we follow this 240 volt line, this cathode line of the V5 tube this way, we'll see it comes down here. Might as well trace it out, I guess. And it sets this center grid, the screen grid is set at the same voltage virtually as the plate. It's not supposed to have any signal on it. And one of the ways you can take, by signal I mean any audio information on here at all. It should just be a steady voltage, virtually the same as the plate. That prevents a bunch of spurious emissions from running from the grid, the control grid, to the plate. So it just calms the control grid down. If you look right down here, several things are happening. One is there is another filter cap right here that runs through the cap through a couple of resistors to ground. So that's filtering out any noise that could get to the screen grid. And also there's a couple of resistors here that work as a voltage divider to give us a reduced DC voltage on this screen grid. So this screen grid here will have DC on it as well. Do we know how much? That's the 78 tube. Screen grid should have about 120 volts on it. Okay, we've got 120 volts on the screen grid here. What else are we doing here? We brought this back through here. Okay, now let's look at where the plate voltage is coming from on this 75 tube right here. So that's this stuff. And connects to there. So we have about 240 volts here, something less than 240 volts here. We're dropping a little bit of voltage as it goes through this field coil. Comes up here, and then we've dropped some more voltage in these matched set of 270K resistors down to 170 volts on the plate of the 75 tube. On the 78 tube, what's going on with that? Oh, right. So this, I'm curious why they have listed. Oh, this is going to be more than 240 volts here. So we don't know what this number is yet. We'll measure it. We know it's higher than 240 volts right here. So when it comes up here, it goes up through this, the primary of the last IF can, and onto the plate of the 78 tube at 250 volts. All right. That leaves us with the plate voltage for our V1 tube, and that's pulling off, tracing this out by ear. Oh, right. There's a connection right here. So this should be our more than 240, or around 250 volts right here, between 200 and slightly more than 250 volts right here. And that comes over here and goes up through this primary of C17 and then to the plate of the 6A7 providing 250 volts DC. Now this brings an interesting point. I don't know if you noticed, but I had this colored. Let me back up so you can see it. I have this colored pink. This is the one that we couldn't get any continuity on because I'm suspecting it's open. And here's a clue that will tell us immediately if it's open or not, and that is if we don't get any high DC voltage on the plate of the 6A7. If we don't get around 250 volts here, we'll know that this primary is open, and we'll have to do something about that. So that's where the voltages come from. There are various other, you're gonna get control grid biasing through a lot of this. You're just by resistor networks here. Various things going on the radio that really don't concern us for the moment, unless they don't work. But what we do know that we need to do is go and strut the chassis up and see if we're getting these voltages that we have on this sheet. So I'll save this and print it, and we'll see what we have. Based on the information that Philco provided, we know we should be getting at 115 volts in. We know we should be getting about 240 volts here, a little bit more. And we can measure that right here on pin, I think that's pin 3 of the 42 tube. Let me check my other schematic, because I can't read that one. Yes, on the screen grid of that 42 tube. So we'll start there. I'll put the voltmeter there. We'll see what kind of voltage we're getting. Actually, I want I'll put the voltmeter on the plate of the 42 tube. Should be giving us around 240 volts. Then we'll start bringing it up slowly with the variac and see given a certain variac voltage, what kind of voltage we're seeing here to see whether our high voltage works or not. So here's the setup. Got the radio. I've got my voltmeter grounded there. I need to get to pin pin 2 of the 42 tube. And the 42 tube is this guy right up here. So let me get in here. This should be pin 2 right there. 42 is our output tube. That looks correct. Turn our voltmeter on to DC volts. We've got the Tipton device over here. The dim bulb is in. We're on dim bulb. We're off here. Variac is all the way down. Turn this on. I'll turn the radio on to full volume. I've repaired that on-off switch and lubed up the volumes potentiometers, so they should work fine now. Okay. If we're lucky, we'll see this little light bulb right here start to light up as things come to life. Or if you were lucky, because you can't see it. Let's see if I can pull this. Yeah, there it is. Okay. I think we're ready to rock and roll here. Oh, the speaker is here. I've got it jumpered in. Don't try to run one of these without the speaker. The field coil and the speaker, as well as the voice coil, are all part of the power supply. And the radio depends on them to get the correct voltages going. Okay, I think we're ready to turn some voltage up. The Tipton device won't start up until about 50 volts, give or take. So we'll start to turn it up. You can see voltage coming up on the variac itself. Although you can't see it, I can. And we're starting to see voltage, high voltage. Well, variations on high voltage over here on the voltmeter. So we're at 38 volts. Let's see if I can zoom in on that. 38 volts, 113 milliamps. We'll go on up to 50. At 38 volts, the rectifier tube is barely able to do anything. So 62, 63. And now we're creating high voltage, 213, 214 volts. And now it's dropping. And the reason it's dropping is it's charging the capacitors. The capacitors are filling up. The filter caps are filling up. And it takes less current, less voltage to keep them going. So we're starting to charge this guy here. And where's the other one? Oh, and this guy right here. Starting to charge those up. Okay, 63 volts, 167 milliamps. We do have our little dial indicators lit up. That's always great. I don't hear anything out of the speaker yet. I wouldn't expect to at this low voltage. I also don't see any smoke. I don't smell anything. I don't hear any crackling, anything like that. So We'll run this up to about 75. Oh, I just heard a squawk out of the speaker. I doubt you caught that. Our dim bulb is not lit. If it is, I can't see it. This is a 75 volt bulb in there. Should be more like a 60, but you can't get those anymore. 75 volts, 220 milliamps. We've got 197 volts on our B plus line, which is right here. That all sounds good. Let's real quick check the filament voltage. That will be on any two big pins. It'll be AC, and it'll be on any two big pins and any of the tubes. So let me switch this to AC. Make sure we've got filament voltage. I'm pretty sure we do. Yeah, right here. Two here. Get in there. How about an easier target? This guy. There, two. There. Yeah, 4 volts. 4 volts AC. That's good. So it looks like we're okay in the power department. Go back to the configuration I had so we can stay on this plate of the 42 tube. Oops, switch this back to DC. Okay, looking good. 195.5 volts for our B plus. We'll go to 100 volts here. Oh, and I hear sounds out of the speaker. Hundred and 101 volts, 350 milliamps. Speaker is making noise. Let's see if the volume pot makes a difference. All right, that means our output stage is working. Okay, 233 volts B plus on the plate of the 42 tube. This is exciting. Now let's check quick. We'll just leave it at 98, 99 volts. Let's check real quick and see what the plates of our other tubes are doing. The 75 tube should be around 170 volts according to this. And that'll be pin 2. And we've got 186 on the plate of the 75 tube. So that's good. We're in good shape so far. That's close enough. We'll check the 78 tube and see what kind of voltage we get on it. That's interesting. put the voltmeter on there and it quieted all that noise right down. So that means I'm picking up some noise. Let's look at the schematic. Had some kind of noise going on. And I measured here and it didn't change the noise. I measured the discriminator, what do they call it? Detector. I measured the detector tube. That didn't make any difference in the noise. I put the meter on the plate of the 78 tube, the IF tube, and that quietened the noise right down. So that's interesting to know. The voltage is correct. It's 240 volts. So that's good. This is good voltage here. I'll just keep in mind that putting a meter on there quietened it down. It might be the tube. It might be signals coming in. Don't know. Just have to keep that in mind. And now we'll check the 6A7. This is the one I'm curious about, because the B+, the positive voltage for the plate, comes through the primary of this first IF transformer right here. And this is the one we don't think works. If this voltage is not about the same as that, then we'll know that transformer, the primary of that transformer, is out. So that's, what pin number is that? Probably also pin 2. Yes, pin 2 is 6A7. Okay, I took the meter off that tube, started making noise again. Uh, 6A7 is right here, pin. Where is pin 2? Pin 2, right here. Ah. We have about 1 volt DC and it's wobbling all over the place on pin 2. So as we were concerned about, the primary of this first IF coil is out. So I'll do just a couple of other things and then we'll have to tackle that. What I'll do is touch my finger to the control grid of the IF amplifier and the detector tube here, and see if we get some noise output. My expectation is that we will. We'll see. Oh yeah. So we got. That's excellent. That's excellent. So we get a lot of noise when we touch the control grid of the 75 tube. By the way, if you're curious why, you'll see if you watch videos of people working on old radios, they touch the control grid cap with their fingers all the time. And that's because the control grid of the cap is at a very low DC voltage. It's just a volt or two. So there's very little shock hazard there. The AC, the RF coming in here is at a very low voltage as well. So it's a fairly safe thing to do. Would I recommend it for everybody? No, I wouldn't, because something bad could happen. You could have a failed component which would put the control grid at a very high voltage, like the coupling cap that we replaced right here. If this coupling cap were shorted, that would put the plate voltage, this 170 volts, on the control grid of the output tube. Of course, it'd be melting down the tube at the same time, but it would give you a shock hazard. So don't do it unless you are pretty confident you know what you're doing. Okay, I'm feeling pretty good about this radio. We know with that our audio stage is working. We know that the detector is working because we can get noise through here. We know that the IF amplifier is working. And we also know, unfortunately, that the primary of the first IF transformer is out. So we'll have to work on that. Checking the Tipton device, we're pulling 370 milliamps at 98 volts. I don't know what this radio should pull in terms of amperage. It's an easy thing to calculate, and I'll calculate that. I'll add those numbers up for us so that we have some idea of whether that's a reasonable number or not. It seems a bit high. On the other hand, this radio burns up a lot of electricity that they found ways around in later versions, more modern implementations. Okay, I'll shut it off. Then we'll go and tackle the first IF transformer.